Good morning, everyone.
Morning, sir.
Good morning, sir.
Good morning, sir.
Okay, so yesterday, if you have seen, we have considered TCP error control, right? How to generate acknowledgement, how we can handle error. Okay, those are the things which we have considered in previous class. So today we'll be going ahead to see how congestion control is established in TCP. Okay, that is what we'll be looking. So you can see here, like in TCP congestion policy, we have slow start, congestion avoidance, and congestion detection stage. These are the three phases which we have in congestion policy of TCP, right? So we have also seen these things in laboratory also, like how congestion policy is implemented in TCP. Now we will try to see the same thing again. So when we consider slow start, we can also call that one as exponential increase. And next stage we are considering as congestion avoidance, where we are seeing additive increase. The last stage we are considering as congestion detection or multiplicative decrease. So within TCP, while implementing this congestion policy, we have three phases. In the first phase, we'll be starting slowly, but when we actually look at the graph, how the congestion window is updated, it will be like exponential increase. Okay, next when we go to congestion avoidance, that means whenever we face any situation like difficult situation with respect to TCP, with respect to network, we'll be going into additive increase or congestion avoidance stage. Then in the last case, we'll be going with congestion detection. Okay, after some issue happened, we'll be moving into congestion detection, and drastically we are going to reduce congestion, congestion window size. Okay. Okay. So see here in slow start, what happens are the exponential increase. We are starting with one, like we discussed earlier, one maximum segment size. One MSS we call it as, okay, one maximum segment size, that is the thing which we are going to transmit in the first case. Okay, whenever I initialize, I am going to start like this. Okay, and I am going to have some round trip time. Okay, after that round trip time, basically you are going to get an acknowledgement. Let us say, see, again here, even though we have transmitted only one segment, after a while, after let us say after 500 milliseconds, receiver is going to send you an acknowledgement. Okay, so you are going to wait till that acknowledgement received. You are not going to transmit immediately in this particular case. Next, whenever you receive acknowledgement for the first one, you are considering like the network is proper, and you are going to consider two segments at a time. Okay, previously I sent one. I'm just doubling that. Now we will be sending two. Two segments will be sent. Okay, and once two segments are received at the other side, receiver is going to acknowledge them. Okay, so you got acknowledgement. I got two segments transmitted successfully. So thinking like still the network is fine, I'm going to double this number, and next I'm going to send four segments. Okay, four segments at a time I am going to send, and when I receive acknowledgement, I am going to make it 8. So if you consider this congestion window size, we are increasing exponentially 1, 2, 4, 8, 16, 32, like that it will be going. Now the question is, till what point we have to go in this manner? The answer is till we reach slow start threshold. We represent that one as SS threshold, right? Okay. So till we reach SS threshold, we will be in this exponential increase mechanism. Okay. So how this SS threshold has been identified is, it depends on various factors. Okay, maybe previously how the performance was there, how the network condition was there. So depending on all those things, we are going to come up with this SS threshold. Okay, so till SS threshold, let us say SS threshold is some 128. Till we reach 128, we will be in slow start or exponential increase. Okay, after we reach SS threshold, what happens is we are going to move into congestion avoidance stage. Okay, So for your understanding, we are just again starting with one maximum segment size, but you can also consider like this is 128 segments which you are sending. Okay, so 128 MSS I am going to send. I get acknowledgement. Next, I am going to make it as 129. I'm going to send only plus one. It's not like 128 into 2, 256 we are going to send in additive increase, but we are going to send only one. So next time I'll be sending 129, 130, 131, 132. Like that we will be slowly increasing. That is why we are calling this one as additive increase. Okay. Till when we will be in this state is till some error happens. Error may be because of RTO timeout, or error may be because of receiving 3 duplicate acknowledgements. Till that point, we will be in congestion avoidance state. Okay, whenever you receive a timeout value or whenever you receive 3 duplicate acknowledgements, we have to again start. Okay, so where we are starting is whenever timeout happens, we are going to go with slow start phase again. Whenever 3 duplicate acknowledgements are received, we are going to go into congestion avoidance state. Okay, the same thing we are representing here. We start our connection here. Okay, we are in slow start phase, wherein we keep on checking if the congestion window size is less than or equal to slow start threshold. In case your congestion window size is less than slow start threshold, we are going to be in that particular state. But whenever you cross that particular value, you are going to move into congestion avoidance state. You will be in this state, like you will be adding your congestion window size plus one always. And whenever you receive timeout, okay, that means sender side, they have set a retransmission timer and they could not receive acknowledgement within timeout value. So what we are doing is we are going to consider it as timeout, and we are moving from like congestion avoidance stage to slow start stage. Okay, so when we are moving like this, we are going to update these parameters. What are the updates? Previously, let us say my slow start threshold value is 100. Now I am going to make slow start threshold value as 50, and new congestion window size we are going to consider as 1 MSS. That means how we started with slow start, in the same way we are doing. Only thing is we are updating slow start threshold value here. Okay, so that is how we are doing when we receive timeout value. Let us say source has received 3 duplicate acknowledgements. When we receive 3 duplicate acknowledgements, basically we need to do fast retransmission. So what we will be doing is we will retransmit the packet segment, and you can see how we are updating. We are going from congestion avoidance stage and coming back to the same state, but with new values. What are the new values we are considering? SS threshold is half of the window, but new congestion window equals to SS threshold. Okay, so in both cases, whether you have timeout or 3 duplicate acknowledgements, slow start threshold value we are making at half of the present window size. But when we consider congestion window size, for timeout we are considering from the beginning, that is one maximum segment size. But when we go with 3 duplicate acknowledgements, whatever the SS threshold we had, that this one we have, right? That value we will be considering, and we will be starting from this particular congestion window size. Okay, so is it clear for everyone?
Sir, can you explain the timeout? How is it going to slow start again, sir?
See, it is not going. We are telling whenever timeout happens, you need to go back to slow start state. Okay.
Okay, sir.
So this is something like, let us say while you are going on highway, suddenly you see a pothole, big pothole. What you will do? You won't be slowing down, right? You will be stopping there. You will apply brake and you will stop over there, and maybe you will try to see alternate paths. But let us say you see some vehicles or the traffic movement is very slow, you will try to reduce acceleration, right? Yes or no?
Yes, sir.
Okay, our signal is there, red color signal. Okay, completely you will be breaking down, and again you will start from zero. But in the case of slow movement of traffic, you will be decreasing your acceleration. Okay, like that, whenever timeout happens, we need to consider like there is a permanent issue or the issue is for long duration. Okay, and we will be going to slow start and we will be continuing. But when we receive 3 duplicate acknowledgements, the issue was only temporary. Only for small duration we had issue. So we can again continue with congestion avoidance, but little bit new values, little bit we can say like hard policy. Okay, this is strict, we can say strict congestion policy, and whatever we have 3 duplicate acknowledgements, that is moderate, taking the into consideration the issue is only for temporary duration. Okay,
Yes, sir.
understood everyone?
Yes, sir.
Okay, so the same thing we are representing here also. Congestion example, we are considering an example and looking how it goes on. So basically we consider slow start threshold as 16, and you can see we started with 1, 2, 4, 8, 16. As soon as you reach 16, we need to move into additive increase. So we are going into this state 17, 18, 19, 20 like that. Okay. Suddenly what happened? Timeout happened. What is the rule we have? When timeout happens, SS threshold should be half of the window size and congestion window should be 1 maximum segment size. So window size is 20 here. Okay. 16, 17, 18, 19, 20. So new threshold will be 10, half of the window size. Okay, and we are starting all the way from 1 maximum segment size again. Next, if you look at this particular value, we will be starting like 1, 2, 4, 8, and I cannot go 16 because SS threshold is 10. So we'll be going to 10. From there again we are going into additive increase. So you can see here this is 10, 11, 12. Okay, we got 3 duplicate acknowledgements. As per this one, SS threshold should be half of the window size. That means 12 by 2, 6. Congestion window size will be whatever the SS threshold we have. That is 6. So you can see here we are starting from 6 again. Okay, 6, 7, 8. And this process keeps on going. Okay. So that is how congestion control is done in TCP. Clear for everyone?
Yes, sir.